Hello guys, welcome back. Today we will be taking a look at another maths AHL question. This is from a past paper. So the question is, by using the substitution u equals sine of x, find the integral of sine x cosine of x over sine squared of x minus sine x minus 2 with respect to x. So our goal over here is to essentially try and get this integral in terms of u. And then of course replace the dx with du and try and simplify it as much as possible, so up to a point where we can just use our basic integration rules to attain our final answer. So what we can do first is, with the substitution u equals sine of x, we can differentiate both sides. So we get du over dx is equal to cosine of x, as the derivative of sine x is just cosine of x. And then we can multiply both sides by dx, so we get du is equal to cosine of x dx. And then if we divide both sides by cosine of x, we can isolate dx like I've done over here. And now we can substitute all of this into our integral over here. So we know that u equals sine of x, so this u replaces sine of x. So now we get u times cosine of x, and then over u squared minus u minus 2. And then I replace this dx with du on cosine of x over here. And obviously the first thing that we can notice is that the cosine of x cancels out. So now we have our integral in terms of u. So we just get the integral of u over u squared minus u minus 2. And the next step that I'm going to do is that since we have a quadratic over here, we can actually factorize it as a product of two linear factors, so that we can later on apply a method called partial fractions, which I will explain later. So if we factorize, in order for us to factorize this, we need to find two numbers, then multiply to -2, and those same two numbers need to add up to -1. So in this case, that's just -2 and +1. So we get this over here, u over u minus 2 times u plus 1. Now we can use a method called partial fractions, where we're essentially splitting this up into two different fractions. So basically what I've done is I've let this equal a over u minus 2 plus b over u plus 1, where a and b are constants, so that we can just integrate this, as we can just integrate 1 over u minus 2, and the constants are just behind the integral. So if we multiply both sides by u minus 2 times u plus 1, we get u equals a times u plus 1 plus b times u minus 2. And now our goal is to find the constants a and b. So what we can do is, to find a first, we can replace we can basically substitute u equals 2 over here, as we only want to be dealing with one variable. So if we substitute u equals 2, we get 2 is equal to a times 2 plus 1. And then if we plug in 2 over here, that's just 2 minus 2, which is just 0, times b, which is also just 0. So now we get 2 equals 3a. And so if we divide both sides by 3, we get a equals 2 over 3. And now to find b, we can apply the same principles. So we can substitute u equals -1 over here. So we get -1 is equal to a times -1 plus 1, that's just 0, plus b times -1 minus 2, which is just, so the whole thing becomes -1 is equal to -3b, and b equals 1 over 3. So now what we can do is that, since we have found our constants, we can substitute this back in here and then integrate that instead. So now we get the integral of 2 over 3 over u minus 2 plus 1 over 3 over u plus 1 with respect to u. So our next step is basically splitting this integral into two different parts, sort of. So we get 2 over 3 over u minus 2 with respect to u, plus the integral of 1 over 3 over u plus 1. And now, since these are just constants, we can just leave them over here. So I've left 2 over 3 over here, and then 1 over 3 over here, and that's just 1 and 1. And if we know our integration laws, this is just ln of the modulus of u minus 2, and this is just the modulus or this is just ln of u plus 1, or the natural logarithm. So we get 2 over 3, that's just the constant, times the natural logarithm of u minus, the absolute value of u minus 2, plus 1 over 3 times ln of the modulus of u plus 1, and then we need our constant plus c, as we are dealing with an indefinite integral. And our last step is to just substitute u equals sine of x, or the other way around actually. So now we get 2 over 3 is times the natural logarithm of sine of x minus 2. Of course, we have the modulus sign still, plus 1 over 3 times ln of the modulus of sine of x plus 1, plus c, as we still need the constant. So that brings us to the end of the video. So the basic idea with such questions is to basically get the whole integral to be in terms of u or t, or basically the given substitution, and then simplify it further using different techniques. So in this case it was partial fractions, and then simplify it as much as possible up to a point where we can just simply apply our standard integration rules to attain our final answer. If you guys have any questions, make sure to leave them in the comment section below, and thank you for watching.